and in this video I'm going to show you a practical application of OpenAI functions, in this case a train trip planner for the Netherlands. First I'll enter a planning query in the field using voice recognition software called VoiceIn. It's a Chrome plugin actually. So here we go. I want to plan a trip from Rotterdam to Sneek on Friday and I want to arrive before 3 o'clock. Now you'll notice that there's a typo. It says plan at trip, and I also misspelled the destination station. It says Sneek and it should be with double E. So yeah, it did get that right. It actually planned a trip from Rotterdam Central Station to Sneek, and indeed it did that for Friday, next Friday, and told it to arrive before 1500 in the afternoon. So that's great. And please note that GPT didn't take the arrival time to be 3 o'clock at night. It somehow figured out that that wouldn't be very likely. Make that before 2 o'clock. And indeed it did that right too. To Amsterdam. So now it actually changed the destination station to Amsterdam, kept the before 2 o'clock and arrival at Friday. Function calling not only opens up interaction with your app through sloppy speech recognition, but it also allows for a whole new breed of typing interaction that we call clip typing. So we was actually able to extract Amsterdam Central and Utrecht Central from these little clipped snippets, and that is actually due to the fact that using OpenAI function calling allows us to limit the scope of the expectation of GPT to a great extent, so it's able to derive much more intelligently what these clip pieces of text mean. Now it's 2:30, but I actually want to leave at 8, and the chat history combined with the limited expectation space allowed it to derive that that would be the departure time for the trip. So I want to arrive at 9. So to have a look at what happened under the hood, we're gonna go back to the top of the interaction chain and click this show code thing, and it shows what GPT actually received when processing these clips. So it got Amsterdam and destination Utrecht, not the stations. It got the trip date out of it, the current time actually, which I gave to it. It says departure, true, that means it's not the arrival time, and it detected the language of English. When it's 2:30 in the afternoon and you say you want to leave at 8, you probably mean evening, but ChatGPT interpreted that as 8 in the morning. But it also detected that I didn't specifically mention a part of the day, so it set it to false, so I could use that fact to use my own code to convert that morning 8 o'clock to evening 8 o'clock. So in the next step we said we wanted to arrive at 9, so it set the departure parameter to false and changed the time to 9 o'clock in the morning, and again the day part is not mentioned, so we converted that to evening time. So let's have a look at the prompt engineering that underlies this application. Large language models like GPT don't have any memory. So you have to put that memory of the previous interactions into the model through the prompt. And these functions or tools that we use to convert expressions into data, they are part of the prompt too. So let's have a look at the prompt of the last message that we sent. The first element of the prompt are the messages. The first message is a system message, which is an instruction to GPT for how it should treat the rest of the prompt. So in this case, it contains the current date and time. It needs to know what date it is, what time it is, so you can use that to understand queries about trip planning. Usually GPT can be hallucinating, but it's also a little bit cautious. So, but now in this case for good user experience, we want it to be very assumptive. So if you enter AMS, you want it to actually assume that's probably going to be Amsterdam. The second message and the third and the fourth message are actually the history of the interaction. Then we see the models, GPT-4, and below that is actually the first function. The description tells GPT to use this function when it sees a user message that could be interpreted as planning a train trip from A to B in the Netherlands. Now, below that are like the parameters that it will have to guess. The first one is origin. It's the origin station in the Netherlands for the trip. And again, it says be very assumptive and accept very shorthands. Then there's a number of references that we actually are mostly time related, because in normal speech we tend to say 8, and depending on the time of the day that gets interpreted in a certain way. So we need some extra information to make that derivation. Normally, when you look at the history of messages, you'll also see the responses of the system. So like when I entered AMS, then the assistant entered, there's a function call, it had these parameters, and then the function, it responded with a specific trip. If you do natural language generation, it will even have an AI message, and then comes the next user message. But I omitted those because they actually tend to add a little bit of clutter to the whole thing, and they cost tokens, so they cost money. At least in this case, it turned out to be better to just use the user messages in the history than to also include the responses by the GPT system. Why did we use GPT-4 not GPT-3? Because GPT-4 is about 10 times as expensive as GPT-3, and it's also a little bit slower. GPT-4 was a lot better at interpreting little shorthands, so I liked that a lot, and it seemed a little bit smarter, make a little bit less mistakes than GPT-3. I'm not really sure in practice which one you should choose. I think you should experiment a little bit. Another notion about functions in OpenAI is that you may have multiples of those. So besides the trip planning function, we also have a custom search function, and actually it looks into all the data I gathered from a scraped website of the Dutch railways. It's another subject actually, but depending on the type of question you ask, it might take a different turn and then answer the question by using this function or langchain tool. So it's also quite interesting. You can actually generate natural language output from your planned trip, and we'll do that in German just to show that you can do it in any language actually.